I don't know why y'all are so scared of long division. Goodness me. No, I'm just playing with you. Hello, everyone. This is the video lecture for 1314 Algebra, section 3.3. We're doing long division. Woohoo! Um, and they're saying long division using these numbers here. They're literally saying 3614 divided by 2 is what number? You probably can just do that in your head, but let's go through it slowly. This is old school here, man. Control Z. Oh, yeah. There you go. Love that Control Z. We're going to have to do it a couple times. All right. I know it's probably been a little bit, or maybe you just did it a few days ago. I don't know. So here we go. Does 2 go into 3? Yeah. How many times? 1 time. And so then I got 1 times 2 is a 2. I'm going to subtract those, and I get a 1. And then I bring down the next number. It's a 6. Does 2 go into 16? Yes. How many times? 8. 8 times 2 is 16. Subtract them, we get a 0. Bring down the next number. So we got, does 2 go into 1? That's not 10, that's 1. Does 2 go into 1? No. So what do I put? 0. I guess you bring down the next number. And so then you say, or you could do the math, but it's just 0. And so then we got, does 2 go into 14? Yeah. How many times? 7. 2 times 7, 14. That 0 down there, that's your remainder. So you have a remainder of 0. So that's kind of nice. So your answer is 1807. So there's your answer for that. If you had to have a remainder box, because sometimes they do silly things like that, this is called the quotient. It's called the remainder. You would put a 0 there for remainder. Again, this thing up here is called the quotient. That's called the remainder. And there you go. We just did long division. That was so fun. Yay! And now do it again for this thing. Yeah. So it is going to be a little bit long, and that's okay, because, well, you could 2 times speed me. How about that? And then I can talk really fast. Let's do the whole thing over again. But again, I want to be a little bit slow. I want to go back and reference, like, how did we do that? And that kind of thing. Okay, so let's do some math here together. Same idea, same principle, same story. I'm going to take the leading terms off to the side, and I'm going to divide them. And I'm going to say, how many times does x go into x squared? Kind of. And you're going to have to say x times. I know there's like 2 x's, but when you divide them, you get an x. So that's your answer. That's what you're doing up here when I say, does 2 go into 3? And you're doing like this in your head. You're like doing some math. Does 2 go into 16? How many times? You're doing it all in your head. I'm not doing any of this in my head. I'm saying doing it manually on the side. I take my leading terms, I divide them, and this is what I get. Right? There's 2 x's up here. It's kind of like saying xx, and then you cancel one of them. You got an x left over. Okay, so that's what's going on, and I line them up in the columns, and there we go. So that's step 1. Step 2, just like we had up here, I said, well, how do we get the next number? Like here, let's do the 8. So 8 times 2 is 16, right? So that's how we're doing that math. So x times x is x squared. X times the 9 is 9x. And notice I'm trying to line them up here. Cool. Now, again, I want to this is the first step, so I'm going super slow. Why do I keep putting a minus sign here? It's because I'm subtracting them, right? So I want to subtract these 2. I want to say minus sign, go. But that is wrong. That is wrong. What you're looking at is wrong. Now it's okay. But like, come on, people. Is any of that really what you want to do? So what I want to do instead is I want to switch the signs. I want to switch the signs. And so this was a positive. Now it's a negative. This was a positive. And now it's going to be a... Oh, come on. There we go. And now it's going to be a negative. I switched the signs. I'm going to write that on the side. Switch the signs. And again, it just means subtract. But it's going to be easier if you do this style. These guys cancel out, and they always should. In a way, it's kind of like right here, 1 minus 1 is 0. So like you're 1 right there as well. You should always get this one canceling out. 14 minus 9 is a 5, 5x, because there's still x's involved there. And then finally, we bring down the next number, a positive 45, and repeat. So here we go. Leading terms off to the side. I got 5x divided by x. What's the result is 5. So positive 5. 5 times x is 5x. 5 times the 9 is not 45 technically, right? 5 times 9 is 45. Yes. And then I want to subtract them. I want to say subtract. So minus, again, I'm going to switch my signs, make that a minus, zero it out. And what do we get here is actually a 0. That would be my remainder. I have a remainder of 0. Now, this is not the only time I'm going to be doing this, okay? It was a little disjoint because I kept going back up and all that kind of stuff. I just wanted to show you kind of the feel of it, and I'm going to go through the whole process again and again. So what did we actually do here? I said x squared plus 14x plus 45, and I'm dividing it by x plus 9. My result was x plus 5 with a remainder of 0. Quotient, remainder. But can I just show you something else? No, Chad, move on. What if I move this to the other side so I don't have, like, just ignore that. What if I move that to the other side so that I don't have fractions anymore? And what you actually would get is this and that. This equals that. What did I just do? I just factored it. Oh, wow. Just saying. So because there's no remainder, I could say that this is a factor. See how that led in pretty well? It's like I was thinking about it. For the first time ever. Okay, let's do it all over again and then do it all over again. This is going to just be long and, well, it is long division. So, yeah, there you go. So strap in with your seatbelt or get comfy. Grab some popcorn or a coffee. Here we go. So taking the leading terms off to the side and dividing them, I should get a 5x. That's not a square down there. This is not a square. I don't know what I was thinking there. Okay, I should get 5x. 5x. See how my numbers make a 5 and then the x's that cancel? 5x times 3x is 15x squared. But you should pretty much always get the same things here. 5x times negative 4 is negative 20x. And then I'm going to subtract. So I need to switch my signs. So minus, plus, zero it out always. And then these guys, when you put them together, you make a positive 18x. Bring down the next term. Repeat. Take the leading terms off to the side. I got 18x divided by 3x. I got 5. Now, if you're ever doing this and you get fractions, then you did it wrong. Okay, this is just a simple My Math Lab class. Okay, so don't overcomplicate it. What? It's not 5. It's 6. What am I thinking? Oh my goodness. Watch to the end, right? Oof. Can I erase that? I should probably just use the Control V thing. Or Control Z. There, 6. That's close enough. 6. Silly me. Anyways, so I got 6 times 3 is 18. And then 6 times a 4 is a 24. That's supposed to be a negative 24. Switch your signs. Once again, you get a 0 there, of course. And then here you get a 3, and that's my remainder. So my result would then be a box plus a box over 3x minus 4. Again, quotient and remainder. I would put in this box 5x plus 6, and in this box I put a 3. And there you go. You got this answer, you got this answer. Cool, cool. Let's do it again. Long division. This one's a lot longer because they're like 4 powers and 2 powers. But I do have to say that I have to write these things in the middle. They're called placeholders. Let me keep going here and I'll explain. Okay. Placeholders. Placeholders. So how many regular x's do we have right there? None. That's exactly right. 0. 0 regular x's. Up here, how many regular x's? How many numbers? 0. It's important because you need to line things up. If you don't do this, it'll probably just all go messy and messed up. You'd have to be super careful otherwise. All right, here we go. Leading terms off to the side. 4x to the 4th divided by 2x squared makes a 2x squared. Again, we have 4 x's and 2 x's, and they cancel, leaving 2 x's behind. So I'm going to put that right here, 2x squared. Okay. Multiplying it, I got 2 times 2 is a 4, x to the 4th. Anything times 0 is 0, x cubed technically. And then 2 times 3 is 6x squared. Switch all your signs. Zero it out. Here we got a 16x cubed, and here we get a negative 2x squared. Bring down the 0. And I know it's silly to bring down a 0, but bring down a 0. All right, doing it again. Leading terms off to the side. 16x cubed divided by 2x squared is equal to 8x. Put it over here, 8x. That's a positive. I just kind of messed it up a little. X. 8 times 2 is 16. Awesome. Anything times 0 is 0. X squared. And then 8 times 3 is 24x. Switch all your signs. Looks a little messy. Zero it out. Negative 2x squared. Negative 24x. And then finally bring down the last 0. Here we go again. Off to the side, leading terms, negative 2x squared divided by 2x squared, you get a negative 1. Negative 1. Basically, negative times everything. Negative 0x. Negative 3. Switch all your signs in the bottom. Zero it out. Negative 24x. And now I got a plus 3. That's your remainder. Whew, and we're done. So, quotient. I'm just going to have 2 different boxes here. Remainder. There you go. So 2x squared, 8x minus 1 is a negative 24x plus 3. Okay. That was a lot. All right. Come on, Chad, tell me. You got Desmos up. You haven't used it. Surely we can use Desmos on this sort of thing. No, I would truly give you, I would tell you what to do. I would. You can't use Desmos. It just doesn't work. Oh, it's so annoying. So, yeah, you're going to have to do this by hand, unfortunately. There's not too many long divisions, but there are a couple on the homework. I would expect one on the exam even. You have to learn it. You have to learn it. You have to do it. Okay, one last thing I want to say. Sometimes they have one big box, and you have to just type the whole thing in there. And so it would look like this. It is a rare case where they want the whole answer. You have to type even this little fraction thing. You have to do that yourself. It's a rare case, but it does happen occasionally. Watch out for those kind of things. Okay. All right. I don't know what this is. Whatever. Keep moving. And finally, synthetic division. Now, some of y'all knew this was coming. Some of y'all were like, what is this? Synthetic division is so much better, so much faster. I'm going to show you how this works. It is so easy in comparison. You don't have to do long division all the time. So it says divide these things. Use synthetic division. So what we need to do first off is solve for x on the outside. And I got a negative 9. And you can call this your 0, your root, your pivot, something like that. It's just the important number. So negative 9 is going to go in its own little box. And then I need to take all my coefficients. Coefficient's a fancy way to say number. All my numbers, so that's a 1x squared, a 14x, and then a 45. See my numbers? That's a 1 right there in the front. Now, I want to make sure that I'm doing this right, because later on it might get more complicated. So I'm going to put a little x squared and a little x right there, just to kind of remind me. It's 1x squared, 14x, number. Okay? Up to you, though. You don't have to do that. I bring down the first number, and we're good to go. This is the setup for synthetic division. Now I'm going to show you the process. Here we go. Negative 9 times the 1 is negative 9. Okay, so I multiplied and I brought it up. I'm going to add this column, 14 plus a negative 9, so basically just subtracting them now. and we get a 5. Repeat. Negative 9 times the 5 is a negative 45. I'm going to add this column to make a 0. There you go. Awesome. So what are we going to say is the answer here then? Like, come on, Chad, tell me what's going on. It's this stuff down here. It's right here. This is your answer technically. And it always reduces down by 1. So this was x squared. Now it's a regular x. And this was a x. Now it's just a number. So your answer is x plus 5, like 1x plus 5. That's a positive 5 technically. And there's your answer. That's your quotient. This number right here, that's your remainder, is that 0 right there. So if they did have a remainder box, you would put a 0. You don't have to write a 1. That's obviously too much. Okay, hold on. Didn't we just do this? I'm serious. Look, it's the same thing. It's literally the same question. So, do you have to do long division every single time? No. Should you do long division when they say to do long division? I would say yes. The reason why is because this does not always work for the ones that we have previously done. You have to be able to find a 0. And like just the last one in particular, I want to take this bottom and solve for x. Here, I'll even write it down over here. Set it equal to 0, solve for x. Solve for x, I'll wait. No, yeah, it's not going to work, okay? It's not going to work. Just stop. Just stop. Just stop. It's not going to work. So anyways. So, okay, I want to do it again for this guy. Can I solve for x here? Okay. That was easy. Numbers. 3x squared, 4x minus 10. Negative 3 times the 3 is a negative 9. I'm going to add this column. Negative 9 plus 4 is a negative 5. Negative 3 times negative 5 is a positive 15. When I add these, I get a positive 5, and that's my remainder. So then this was x squared. Now it's going to be an x. That's my number. So again, it's 3x minus 5. And then my remainder is a 5 over the original x plus 3. Quotient, remainder. Look how fast that was. Look how fast that was. That was awesome, right? Uh-oh. Want to do this long division? Nuh-uh. Solve for x. You get a 2. 2. And then I got 5x to the 6. I got negative 5x to the... Wait. I messed up on purpose. So if you notice here, where's my 5th power? 0x to the 5th. Yeah. Placeholders. Oh. Placeholders. We already talked about that earlier. Negative 5x to the 4. There's a cube. Nope. 0x cubed. 3x squared. Is there a regular x? Nope. 0 regular x's. And then a 9. So, placeholders. Very important. If you didn't have the placeholders, it'd mess up. That's why I also write these x's on the top. You don't have to do that. It's not part of the math. But I write it so that I remember, oh, look, I got a 6. And then all of a sudden a 4? 2 times 5 is 10. Plus 0 is 10. 2 times 10 is 20. 20 minus 5 is 15. 2 times 15 is 30. 30 plus 0 is 30. 2 times 30 is 60. 60 plus 3 is 63. 2 times 63 is 126. 126 plus 0 is 126. And then finally, 2 times 126 is 252. Yes. Plus 9 is 261. There you go. So these are your answers. Notice that this is now x to the 5th, x to the 4th, x cubed, x squared, x, regular number, remainder. That's your final answer. Oh my gosh, it takes longer to write out the answer than to do the math for it. When have you ever been able to say that? I guess that's a good problem. I don't know. There you go. All right. Yeah, sometimes you got to write it all out like that too. Cool, huh? Synthetic division. A little bit easier. Can I do that in Desmos? No, not really. Not really. Sorry. Okay, remainder theorem. So they're going to go blah, 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 synthetic division, blah, blah, blah. Yay, synthetic, yeah, Okay, hold up. F of x, f of 3. What do they want? What do I do? X equals 3. I'm plugging it in. I'm going to write that down. Plug it in. I'm putting a 3 wherever there was an x. Not percentage of. I'm putting a 3 wherever I see an x. Did I type it right? Did I? Hold on. I have my book here. I want to just triple check I'm doing it right. I messed up somewhere. What did I mess up? 3. Oh, I put a 30. And you're like screaming at me. You put 30. You put 30. Do it in the comments. Watch to the end. Anyways. Cool. It's negative 14. Yay! I plugged it in. What they're saying here is you could use synthetic division to get the same result. And it would be the remainder. So you got 9, negative 3, negative 9, negative 4, negative 12, negative 14. There you go. So they're the same. But I would personally just plug it in. It's even easier that you don't mess it up like I just did if you type the original. I'm working on the other problem, by the way, now. And then you say x equals negative 4. And, like, you're done. That was it. You're seriously done. That's all you have to do. You're done. There's nothing else to learn here. You're done. It's a synthetic division remainder or plug it in. Either way is fine. I don't even know what that is. That's fine. So it's totally important. Everything is so important. It's tying back in, says that synthetic division, you get zeros for zeros. Okay. Yeah, it says factor. It's a 0. That's kind of what they're trying to get at. Okay. X equals C. Ooh, that's even better. Look, I made it better. I made it better, guys. I made it better. Blah, blah, blah. So it says, this is solve this equation and find all the zeros. And they say that negative 1 is definitely one of your answers. Hold on. Negative 1. Yeah, there's my answer. Of course, there's more. And if you want to know how many answers we're expecting to get, it's right there. Your degree is telling you how many answers that you should be looking at. So I've got negative 1, and I'm looking for now 2 other ones for this. What you do is synthetic division. So negative 1, and then you go through and do synthetic division with this and reduce it down. Negative 1 times 1 is negative 1, minus 5 is negative 6. Negative 1 times negative 6 is positive 6, plus a 2 is going to be an 8. Negative 1 times 8 is negative 8. 8 and 8 make a 0. Anyways, so this is x squared now, regular x, blah, 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 blah. We got a 0, so it obviously is a 0, that kind of thing. But now we're left with x squared minus 6x plus 8 is equal to 0. And now I can factor. So what two numbers add to 6 and multiply to 8 is 4 and 2, negative 4, negative 2. So then we got x is equal to a positive 4, x is equal to a positive 2. There we go. We just did it. There's your answer. Desmos. All right, so Desmos would do all this for you. Ha ha ha. And it is really super sweet. When it comes to solving for x, thing is great. I'm going to zoom out a little bit. No? Did I know I mistyped it somewhere. That's a square. Okay, so much better. There's your answers. Negative 1, 2, and 4. Da, da, da. It doesn't matter what order they're in. So you could avoid all this, go right to Desmos, and you're done. I get that. And that generally is okay, especially in this section. I got to say that. But you won't have very many of these anyways. I just wanted to tie in how the synthetic division works. You will have to use some of these techniques in the next section. Okay, so just, it's not completely useless. For an example, let me do this one on Desmos graphing, and then we're going to go back and do a lot by hand. Okay, so we got this, this, and this. Ha ha ha! Okay, so anyways, let's go one by one. I got a negative 1.5, and as you guessed, that's my 3 halves. So, boop, boop. So we got x is equal to negative 3 halves. That's definitely one of the answers. That was right there. So let's get this negative 0.333. Yep, that's sweet, super sweet. Nope, it's not super sweet anymore. Sorry, it's I'm putting the microphone right next to the keyboard just because I think it's funny. And then finally, this one right here is a 0.5. You could probably guess that one is a half. And we're done. There it is. This one, even with synthetic division, is not super great. But I want to show you it a little bit because it's scary because it has fractions. So I got negative 3 halves times the 12. Now the 2's are going to cancel, leave a 6. 6 times 3 is 18. 16 and 18 are going to make a negative 2. So multiplying these two guys, the 2's canceled, the negatives cancel, leave a positive 3. So I got a positive. No, it's a negative 2 now. It's negative 2. Again, the same thing. We get a 3 zeroed out, and there we go. So now we're left with this guy, and it says factor it. And honestly, this is kind of tough. You could use quadratic formula. You could do the AC method. You could factor a 2 out. There's so many different ways, or you could just use Desmos. And it works like 99.99% of the time, okay? So at least in this section. It won't work in the next section every time, and I'll warn you about that, okay? So there's your process. I'm not going to finish that. You kind of get the gist of it. Keep moving. And so this is the last question? Yeah. So this one is very important. I've seen this on exams and quizzes and stuff. And I just want to say for the record here that when I look through an exam and try to give partial credit back and stuff, I'm looking at what's wrong. I look at the wrong questions. I don't click on the questions that are correct because I already know you got them right. I'm not going to take points off or something. So I go to the wrong questions. If I've seen this, that means that people got it wrong. You get my picture here now. Are you getting it? You getting it? So if I'm seeing this and I say, oh, that's on an exam, it's not just that it's on an exam, it's that it's on an exam and people get it wrong. All right, there you go. So how do I do this problem? It's very simple. It might need a little bit of Desmos here in just a second because I'm not really good with decimals. But what we're doing is dividing these two. This one right here, I need to solve for x. Now, I know it's like a little funky, but solve for x, you actually get a negative 0.5, and that's what we're going to use for synthetic division. We're going to use a decimal. These numbers, these coefficients are going up here, like that. So this is x cubed, x squared, x regular number, bring it down. Now, the only way people get this one wrong is, for one, they just don't know what to do. But the second is these decimals, and this is where I mess up, is the decimals. So I got 0.5 times 0.1, and you're like, 1 times 5 is 5. So it's 5, right? It's 5. It's awesome, 5. Okay, hold on. I'm not very good with these decimals. I blame the public schools, right? They had to teach me fractions for how many years? Fractions are only good in cooking. I'm just playing with you, okay? But decimals are very important, obviously, and we're not taught them as much. I don't know. It's just a funny little thing here in America. So do it again. 0.5 times the 1 is a negative 0.05. And so when I add these, I get a 0.2. And so let's do it again. I got a negative 0.5 times the 0.2 is a negative 0.1. Zeroed out, and there we go. This is your answer. And again, this is x squared, regular x. There we go. This is what my math lab wants you to type in, okay? So that's your answer. That's what you put in the box. It's not hard. It's not hard. It is weird, but it's not hard. Watch out. There you go. And we did. I think that's the end. Yeah, that's the end. Thank you very much, guys, and have a great day.